Alright, so let's finish up the lesson from today, and then I'll show you how to do the homework assignment so that you can check your answers before class tomorrow. So I know at the end of the period I kind of went through number 5 quickly, so I want to just go through that one more time with you. So you notice that they're giving you the inverse and they're asking you to find the original function, right? So what we know is that the inverse of an inverse is the original function. So essentially this is just another way of asking you to find the inverse of the given function. So I'm going to start by doing the same steps I would have done today in class. X equals y minus 1 to the third power plus 3. So all I'm doing is switching where the x and the y values are. To solve this, I would start by subtracting 3 to both sides. So now I have x minus 3 equals y minus 1 to the third power. Now, to the third power, we know that we can take the radical with a cube root there, or we can raise that to the 1/3 power to both sides. Either way is totally acceptable. I'm going to use radicals. So I'm going to do the third root of x minus 3 equals y minus 1. Last thing we have to do is add this 1 to the other side. I always like to put it in front of the radical just so it doesn't get confused what's underneath, what's not. So then our final answer would be f of x. Notice I'm using f of x, not f negative 1 of x, because we're trying to go from the inverse back to the original, equals 1 plus the cube root of x minus 3. That would be a perfectly acceptable answer. Now the alternate answer here, just because we know that that can always happen, would be f of x equals 1 plus x minus 3 to the 1/3 power. Those two things mean the same thing. Okay, so the questions that we didn't do in class today. Number 6. Does the function f of x equals x squared minus 6 have an inverse? So the first thing I want to do is I want to graph that, even though many of you probably know what that looks like. But here's your graph. So we see that this graph is a parabola. A parabola fails the horizontal line test. Because it fails the horizontal line test, we know it is not a one-to-one function. So the answer to this question is no. And the reason why is because f of x is not 1 to 1. And remember, what 1 to 1 means is that there are multiple x values that have the same y value. So on that particular function, you might have an x value of, let's see, like negative 3 that has a y value of 3, and then an x value of positive 3 that also has a y value of positive 3. So we see there are two different x values that have the same exact y value. That makes it not a one-to-one function. Now, everything that we've done over the first 2 lessons of this chapter is really us trying to figure out whether or not we can find inverses of exponential functions. Essentially, this next chapter is an extension of the exponents unit we just finished. So question 7 says, why must every exponential function have an inverse? So if we look at a couple exponential functions, so I graphed just the basic one like 2 to the x, that's the red curve, negative 3 to the x, so I reflected it, and then I gave you a kind of crazy looking one here. Let's even make this in the exponent. So we see all 3 of these graphs, although they have horizontal asymptote lines and they go on forever, they all pass the horizontal line test. So no matter what changes you make to the original function here, you're always going to get a one-to-one function. So what we can say here is because all exponential functions are 1 to 1. If you were to play with your calculator and change any of the parameters or any of the different things that we did with translations or reflections or dilations, it's always going to give you a function that's 1 to 1. And then here comes our problem. If you try and find the inverse of something that's exponential, like a basic exponential function, y equals 2 to the x, you get x equals 2 to the y power. The problem that we run into here is there is no algebraic method that we know right now that allows us to get that y by itself. You can't do anything. right? You might think that you could divide by 2 or multiply by something or raise it to a different power. Nothing that you know how to do right now allows us to do that. And that's what we'll actually talk about in the third lesson. So there's your lesson. At this point, I would want you to try the homework assignment before I go through these answers. And then you can check your work later. At any time, if you want to, just check your work or pause it and try it again. You can. All right. Also, there are a couple of these questions in the homework assignment that do have alternate solutions, so answers that look different than the one that I have. So don't just copy down what I have. Ask me tomorrow, and we can see if your answer is right or wrong. So let's start by looking at number 1. Number 1, we see we have a linear function, so we know that that function is going to be 1-to-1. So just like we did in class, we're going to switch the x and the y value. We want to get y by itself, so we would subtract 1. So x minus 1 equals negative 1/2 y. And we want to get rid of negative 1/2, so I'm actually going to multiply both sides here by negative 2. That's going to give me negative 2x plus 2 equals y. Then we can say, because this is an inverse function, we'll put it in our correct function notation. And there's our answer for number 1, f of x. That one wasn't too bad. All right, so let's look at h of x. So same rules apply. We want to switch the x and the y. Notice nothing changes about the function. We're just flipping the x and the y. Now to get rid of this third power, I want to raise both sides' exponents to 3. Because that's going to cancel all that. So now I'm going to be left with x to the third power equals 2y plus 4. If I subtract 4 from both sides, I'm going to get x cubed minus 4 equals 2y. Now we have to get y by itself still, so I'm going to divide everything by 2. Now, remember, when you divide everything by 2, you can separate it all out, because sometimes one term can be divided by 2 and the other one's not divisible by 2. That happens in this case. So dividing by 2 by everything is going to be important. So this was h of x, so we'll make this h negative 1 of x equals x cubed over 2 is the same thing as 1/2 x cubed. I just like writing it that way. It looks better. Minus 2. Because 4 divided by 2 is 2. Now again, another way you could show that would be x cubed over 2. I would even probably accept it if you put x cubed minus 4 all over 2. Either way, totally your choice. Okay. M of x. So if we were trying to do m of x, I would start by switching the x and the y value. And then cross multiplying. So when I multiply anything by 1, it becomes itself. And if I multiply x, it's going to be 4x minus 3xy. Now I know in class we said that we were comfortable with this, but let me use some color here just to make sure that we're all comfortable with exactly what I'm doing. So I'm taking the 3xy and I'm going to add it to the other side. And I'm going to take the 1 and I'm going to subtract it to the other side. By doing that, on the left-hand side, the 1 no longer will be there, but I will be left with 2y plus 3xy. On the right-hand side, the 3xy is going to cancel, so I'm going to be left with 4x minus 1. Then we see on the left-hand side we have a common factor of y. So I can factor that out. I then can divide both sides by whatever is attached to y, so 2 plus 3x. And this was m of x, so we'll say m negative 1 of x equals 4x minus 1 all over 2 plus 3x. And the last one. So again, we'll first start by switching x and y. We now have to get rid of this 3. And that -1. Never want a negative there, so we'll get rid of that by dividing -1 on both sides. So that's going to give me -x plus 3 equals 2y plus 5 to the 3rd power. To the 5th power, sorry. I thought that was a 3. Now, to solve this, we want to get rid of that exponent of 5. So I could take the 5th root of both sides, or I can raise both sides of these equation to the 1/5. That's how I'm going to do it for this one, just because I did radicals before. Again, you could do it either way, it doesn't matter. So if you do that, you're going to wind up having this -x plus 3 to the 1/5 power equals 2y plus 5. I'm then going to subtract 5 from both sides. So I have -x plus 3 to the 1/5 power minus 5 equals 2y. And then divide everything by 2. So you're going to have -x plus 3 to the 1/5 power minus 5 all over 2 equals your function g -1 of x. Now if you didn't use fractional exponents there, if you used radicals, this would have been the 5th root of -x plus 3 minus 5 all over 2 equals g -1 of x. Also, I probably wouldn't put the minus 5 there. I'd probably put it out front. But either way, it is correct. All right, the last one says, if k of x equals sine of x, is k -1 of x a function? Explain your reasoning. So the sine function, we know what the sine function looks like. That's one curve of the sine function. We know that the sine function is actually going to fail the horizontal line test. So the answer to this question is no. Because k of x fails the horizontal line test. And what that actually means is that there are multiple x values that have the same y value. So essentially the y values repeat. All right, so some of these y values are going to be the same. And we saw that when we talked about trigonometry. We saw that there are some x values or some angles for sine that have the same value in quadrant 1 and quadrant 2. Hopefully this helps. If you have further questions, please make sure you ask me in class tomorrow. Have a great night.